So jumping right in, we are a new company founded this year. It's just 25 people. That is vast majority engineering, although with the addition of Mark Glasgow as our head of sales, we are now ramping the sales team and actually have product in market. The company is pre-Series A at the moment, angel funded, and you might ask, how do you have a product in market? Because this is actually a very substantial amount of engineering. It's something that I personally have been working on since, well, actually not just since when I left Fusion.io, but even as I founded Fusion.io, was a realization that a technology would need to enable this type of thing. So this technology has been in development for a while. From the highest level, this is about access to unstructured data everywhere. Our belief is that you shouldn't have to think about getting to your data. It should be like the air you breathe, an autonomous function, where it doesn't matter what data center you're in, what cloud you're in. Your data is simply there, being served from existing infrastructure at full performance, unhindered, and able to feed data. You shouldn't have to think about data and how to get it staged and moved. So we'll talk a little bit more detail about this as we jump in here. But first, let me describe what the product is. So the product at the highest level is data as a service. Data presented decoupled from the underlying storage. The fundamental innovation to make this possible is the separation of the metadata. That is, after all, how we think of data. When we think of data, we think of the name or the directory it's in or what the thing is. That's metadata. So at the heart of data as a service are actually metadata services that provide the namespace, the traditional file system metadata, as well as enhanced metadata that make it faster for folks to find what they need from within potentially a very large universe of data. Those things include what you might expect: catalog services, index and search, ways to articulate what the governance requirements are on the data. Metadata is data about the data, and that includes how we identify it, how we think about it, what we think is in it, as well as how we want it handled, what I like to talk about it as care and feeding of the data is. So first and foremost, our product is a metadata service. But what makes it truly unique is that is put into tight coupling with presenting the data itself through that metadata. In other words, we put the data in a feedback control loop where the metadata is able to manage the data across the infrastructure and render it as file, shared file, and object within the multiple data centers. So in other words, it presents a file system view, NAS, NFS, SMB, presents a file system view to your data, and it presents an object bucket view of your data. Those are converged. And it actually manages the accessing and realization of the data objects across the infrastructure at the behest of what the metadata control plane says. Let me take a brief stop here to see if I've created any questions about this.
You had me at data.
I had you at data. Well, metadata is even better.
One man's metadata is another man's data.
There you go. The product is deployed as a service, a pay-as-you-go service on a consumption model, the amount of data under management. It is an on-prem, a virtual appliance, or containerized service, and in the cloud, it's a service in the cloud. So this is a hybrid cloud product that's made to run both on-prem and in the many different public clouds. We'll talk about the partnerships there, but as you might expect, given it needs to be very broad.
A question on,
yes.
We say by volume of data managed, by what's the unit, by volume gigabyte or volume number of objects?
It's the volume size of data under management. Yeah, yeah. That's a
Subtlety.
It's a subtlety, and there's a debate about it. It's still internal. We're new enough that we're not necessarily set in our ways on that, because given the nature of the product being so much about the metadata, then that might make sense on a number of data objects whose metadata you're managing.
Exactly.
What we do know is it's consumption-based, whether it's rated by the size of the data in those objects or by the size of the metadata or some combination thereof. Yeah.
Okay.
Right. So, and just to frame this, we're talking about unstructured data, and by that I mean file, shared file, and object data, and for hybrid cloud environments. So, let's jump into the technology and start from the inside out. The technology starts with something you might be familiar with from some of the work I was doing prior. And that is the ability to decouple where data physically resides from the view of it through the namespace, and allow any piece of data to be stored on any storage, even multiple instances of it across the storage, and movable at any time without interrupting access. So this dynamic mobility of data is completely hidden behind the notion of it's the file foo, regardless of where all it may have copies across infrastructure. So the first and foremost, this is about the plumbing that makes it possible to separate the data itself from the metadata about it. Let me draw a diagram on the board here, if I may, to try to set the stage, because I think this is an important area here. So just start with a little bit of history. When we started with block storage, and even shared block storage, where you're talking something like SCSI, the file system generally resides on the client. And this is what presents the namespace and puts the metadata down, because after all, block storage is just raw blocks. Okay? That has some advantages, especially when it comes to performance, because the metadata is all right here local, etc. Now, it has limitations in terms of the convenience and shareability of it. So the world kind of introduced this notion of putting the file system down in the shared device, and then using protocols here that incorporate the file system with it, whether that's NFS, the networked file system, or SMB, very descriptive names. That allowed the different users or the different applications to see the data through a common metadata view. If this was SAN and this is NAS, what we are introducing is fundamentally different than either of them, and fixes it so that you can take shared file data to the cloud. Because you'll notice that when we went to the cloud, your NAS and shared file kind of got second rate. We went to object storage. We further abandoned performance, and for the sake of easier shareability, talk this over REST APIs. So object storage is really just an extension of this, where we've accepted a much, much slower interface and much less coherency to do it. So object really isn't that much different, other than it takes it to the extreme so that you can geoscale it, shall we say. Well, what we're doing is we're fundamentally fixing this. so that you can geo-scale. You can get cloud scale from a shared file system model. And the way that's done is by taking the metadata and serving it from a separate control plane. This is not unlike what was done in the software-defined networking space. To be able to have high performance, you don't want to handicap the performance of your network, but you want to be able to have a control plane and manage it. So the networking control plane is separated from the switching infrastructure. That's the same exact concept here, where the file system is put on the side. And that allows the clients, or the clients talk here for metadata and receive routing information to go and get the data. So this is, it's like using DNS. Can you imagine if your DNS server had to proxy all of the traffic? Well, this guy is resolving what the file foo is, and then subsequently having to pass all the traffic through it. So having your control plane and your data path coupled is akin to having your DNS infrastructure have to also pipe all the information around the internet. It wouldn't work. The separation is what makes this key. And we're talking about this as data as a service, because this allows you to access your data across the infrastructure as a service, abstracted away from where it physically resides. The bottom line is, this is giving you the same separation of infrastructure from consumer that VMware did on the compute side to separate the logical workload from the physical server. Taking the metadata out and having a separate control plane was really made possible by being able to enhance the fundamental plumbing of the storage networking protocols. And this is why it's such a key thing that our CTO happens to be the Linux kernel author and maintainer of the NFS stack. Another key enabler here is that Linux has won the OS wars. It's not like there aren't other OSs, that's true, but when it comes to cloud and cloud scale, the world has really changed. So all of this technology that I'm talking about that enables this, that fixes it so you can use a as-a-service model for serving data by having the metadata off to the side, all of that is now upstream in Linux and open source. Because Trond Mikkelbus, our CTO, is the kernel maintainer, and this team has been responsible for over 70% of the enhancements that have gone into Linux upstream, and it's now coming back down in box through the distros.
So I get the picture. Okay. Mm-hmm. It looks really familiar, actually, but because you did it already in the past, right?
So that's why we're showing the inner layer here. This is something that that we started working on, because this, the interesting part about this is, as cool as it is, it doesn't really solve the problem, because in the end you need additional technologies, and that's where we go back to the board here. There's 2 additional layers before you really get utility. So what if I can have anything on any piece of data? And by the way, at the granularity of the individual data object, not whole volumes, not massive sets, but the individual files with their own metadata directing it. The key is to introduce enhancements in the metadata. Now that it's separate, it can become much richer. And we're talking not just, 2K worth of tags that you can put in an object store. And this is one of the areas we're going to go into a deep dive. But a very rich world of enhanced metadata that allow those who use the data to understand better what they have, where they need it, to find it, and so forth, but also allow it to be put into a feedback control loop with the middle layer. So the metadata is not only important to the consumer to know what he's got and to express what he wants, but it's ultimately that statement of intent, what is wanted vis-a-vis the care and feeding of the data, that informs the orchestration system, the data management, the hybrid cloud data management layer as to what is desired for the data. So these three layers work together in concert, and only once you've gone all the way up to the top can you actually, I think, be viable in the market. Because one of the fundamental principles behind cloud is to get to the point where you can ignore the infrastructure and take it for granted, because you're giving it to somebody else, right? So the only way we can do that is if we pull the level up high enough so that the data consumer can self-service, so that he can use what he needs and be able to just forget about what does it take for the system to realize his intent for him. So we have to have a rich language of intent so he can express what it is he wants, what level of performance, what data centers it needs to be on, how many copies, what kind of durability, availability, basically any directive about how you want the data cared and fed for ought to be, go get it, data about the data. That's what it is. But it ought to be in the control plane that can use it to automate the rest. So that's why we have these three layers. If you think about it, what we are doing is we have introduced an abstraction which separates the data consumer side and the data, the storage infrastructure side. And that's really what's necessary before we can manage data in the cloud. If we have here the people who consume the data and down here the infrastructure, these need to be separated. And that's what these three layers are. The metadata layer is largely upward facing. This, by the way, is the profit center of a business. This is where value is generated. Down here, the infrastructure side, this is where it's your cost center. This is about efficiency, reducing your cost, reducing your risk. Over here, it's more about agility, finding what you need faster, getting it to where you need it faster, et cetera. By introducing a layer of abstraction, and if you've been in technology, you know that is the key, we separate data from the infrastructure and it allows both of these things to become more efficient. Let me use an analogy that's in the container world. We've taken this to a certain extreme. There are a gazillion different types of storage for containers. And the thing about them all is you can bring them into existence through an API and you can throw them away. Your storage there's a huge diversity of different types, and it's easy to provision and deprovision the storage programmatically. I was listening to somebody in the container storage business, and they were talking about how storage ought to be like cattle, not the family pet. That in the past, your NetApp or whatever has been the pet that you have to nurse back to health, right? But they say we want the storage to be something that when it gets sick, you simply take it out back and shoot it. You replace it with something else. The problem is data really is the value in a business. We have one of our early customers is in the oil business as a private cloud that does analytics on oil field data. They have many different customers who own oil fields and production rigs and so forth, and they take those data sets into their private cloud, perform analysis to be able to make quick assessments about this part on this rig, how frequently does it wear out, when are you going to need one. It's some really cool AI stuff to get more value from oil fields. In the oil business, there's almost as much value in all the seismic data and all the information about the rigging and stuff than in the ground itself, because the ability to get in and extract the minerals and get out quickly. So Where was I going with that? I got distracted on telling the use case.
The problem with shooting data.
Oh, shooting data. Yeah, the value is in the data. So until we decouple the two, you'll never be able to solve that paradox of how do you have the, stuff that's so valuable that you really have to keep it around and care for it versus the storage itself that are disposable. Okay. So once you're able to present data through the lens of the metadata and manage it through the lens of the metadata, then you can think of it as truly data like air, simply everywhere. As a matter of fact, the metadata can be aggressively replicated across the globe at different data centers so that you can have the view of it, and when you go to access it, it can get the data to where you need it in a on-demand basis. So at the heart of the product is the fact that the data itself is both proactively aligned to what's intended through policy and the machine learning optimization, and it's on demand to get there. So we're going to go into the technologies in these layers, but suffice it to say that there are substantial innovations to each of these to make it possible. And one of the most important points, though, is that once you have the layers stacked up, then you can truly cloudify the world of unstructured data, because you can put it into a self-service model to where the consumer can get what he needs and manage what he needs without having to worry about the nuts and bolts of how it happens under the covers. And that won't happen with the silo-based data management where you say this app on this storage and this app on this storage, this app on this storage. This kind of turns the equation by having that abstraction. Okay, that's the introduction to Hammerspace technology. It is AI and machine learning in that middle layer. We're going to talk about how that works to take the intent that's expressed in the metadata and map it to the infrastructure's ability to dynamically orchestrate data around. We'll actually show some of these demos.
Does it mean that the policies are created from some fancy AI algorithms, or it's
this?
Because, you know,
yeah.
Can we wait on that question until we get a chance to show the demo?
So we'll show the demo, but what you'll see is this layer allows you to put business logic and policy, and then those intents are evaluated, and the data is aligned to meet them to the best extent possible, and that's where the machine learning comes in. So it's a sandwich of the two. That's the brief way to do it.